supply. MCP I will switch on. Then I will close the breaker. This breaker is presently in the open condition. Now I will close this breaker. Right. Then these two terminals T1 and T2. T1 and T2 terminals I have connected to the current source, red and green wire, through which I am going to inject the current. So between T1 and T2 the thermal bimetals are there in the circuit, and this red and blue wires, these two wires are coming from the under voltage release, which are connected to fixed 240 volt supply. So now presently the breaker is in a closed condition, right? Now I will inject current. So for that, this current source we are going to use, and this is ASS is 50 ampere, CSS is also 50 ampere, and the tab I have used is also 50 ampere. So that sequence is matching. Now I will inject current through this 13.2 ampere current, that is 150% of 8.75, that I will pass. The minimum and maximum trip time I am getting is 30 seconds to 150 seconds. For 200% I am getting 15 to 50 seconds, and for 300% I am getting 5 to 15 seconds. And how I got this minimum maximum limits, I got it from this standard curve given by the manufacturer. So this is the standard curve given by manufacturer. This is the multiple of set current x-axis and actual time on the y-axis in seconds. So this is multiplier is 150%. So for this is minimum is 30 seconds, maximum is 150 seconds. Similarly for multiplier 2, that is 200%, this is the minimum time, this is the maximum time. And similarly for 3 multiplier, that is 300%, this is minimum time and maximum time. So how this is how I am obtained this minimum maximum time from this range of this minimum maximum time from this standard curve given by the manufacturer. Now let us inject. I am injecting the first reading, that is 13.2 ampere, and actual time how much I am getting I have to note down here. As soon as I inject this current, I will start my timer. So timer will start, and when the ACB trips, at that time I will stop the timer, and that tripping time I will note down in the observation table. Okay, so this is my timer. So here you can see this is the timer. Okay, so I will inject now current, at the same time I will start the timer also. So I have injected the current and I have started the timer also. So see, I am injecting current. How much I have to inject? 13.2 ampere. So I am injecting 13.2 ampere, and once I inject 13.2, yes, 13.2, timer is still on. So you can see now the breaker will trip after some time. At that time I will stop the timer. Still the breaker is in a closed position. 25 seconds elapsed. 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. Still the breaker is in a closed position. Now breaker will trip. See breaker is, I will stop this. So 48 seconds I got. So after 48 seconds the breaker has tripped, and this current I will make 0. So I got in this way the first reading. How much time I got? 48 seconds. So I will write down here, actual time is 48 seconds. So between 30 to 150 seconds we got this 48 seconds. So our breaker is okay, because we got the actual time within the limits, minimum maximum given by manufacturer. So our breaker is okay. That remark you have to write here. So this is our first reading. Now we will take second reading, for which we have to pass 17.5 ampere current, but for that we have to wait for 10 minutes, because the thermal bimetal has to cool down, otherwise we will get the false reading. So we will wait for 10 minutes, and after 10 minutes we will take the second reading, for which we will inject 17.5 ampere current, right? So thank you. Now let us take the second reading for the overload test on ACB. Now for this reading we have to pass 200 times of 8.75, that is we have to pass 17.5 ampere current through the ACB. I have made the main supply on, then I will switch on the MCB. So MCB is switched on. Now the breaker is in a open position. I want to close the breaker. So see, I am closing the breaker. Spring is charged first, and then now see, breaker is closed, right? Now the breaker is in a closed position, and now I have to inject current how much? 17.5 ampere through this overload, for overload testing. Okay, and at the same time I will switch on the timer also. So see, I am injecting the current. So I have injected the current and I have started the timer also. And see, now timer is started and I am injecting the current. I have to adjust this current to 17.5 ampere. So I am adjusting it to 17.5. So see, it is 17.5, right? 17.5. The breaker is in a closed position. Timer is started. It is 18 seconds. Now the breaker will close. The breaker will trip after some time. See, yes, breaker is tripped. And here you can see I have stopped the timer. I got 20. I will write over here for second reading. Second reading I got here timing 28 seconds. Now this 28 seconds is between the limit of 15 to 50 seconds. So again our breaker is okay since actual time is within the limits minimum maximum specified by manufacturer. So that remark you have to write over here. Right. So in this way we have completed now our second reading. Now we will take after 10 minutes break we will take the last reading for which we will pass how much 300%, that is 26.25 ampere current, and the time I will get between 5 to 15 seconds for the third reading. So thank you. Okay, so let us take the last reading of overload test on air circuit breaker. So I will switch on the MCB and now I have to close the breaker. See, the breaker is in a open position. I will charge the spring and then the breaker is now in closed condition. Now I have to inject here a current of 26.25 ampere, that is 300% of 8.75 ampere, right? And the limit is 5 to 15 seconds. Okay, so I will switch on the timer also. So this is my timer. I will inject the current and as soon as I start the timer. And how much current I have to inject? 26.25. So see, I have started the timer and here I have injected the current 26. See, breaker is in a closed condition. See, I have injected 26 ampere current. Breaker is in a closed condition. Now it will stop. So see, I have stopped the timer. I got here 14 seconds. Okay, so 14 seconds. So I will write down here the actual trip time is 14 seconds, which is within the limit of 5 to 15 seconds. So I can say that our air circuit breaker is okay. So that remark I can write down. So in this way, we have conducted the overload test. Initially, we have injected 13.2 ampere, for which we got actual time of 48 seconds. For second reading 17.5 ampere we have injected, for which we got 28 seconds actual trip time. And for third reading 26.25 ampere we have injected, for which we got a 14 second actual time. And this is the range. So all the readings are within this minimum maximum range specified by the manufacturer. Therefore our air circuit breaker is okay. Okay, so that is how we have completed the third test, that is the overload test. Now in the fourth part, the next part we will see the last test, that is the short circuit test. Right, thank you. Short circuit test on the air circuit breaker. Supply is switched on. Now MCB I will switch on. MCB is switched on. Now I will close the breaker first. See, breaker is in an open position. So I will close the breaker. So spring get charged. And now I will close the breaker. Yes, now breaker is in a closed position. Okay. Now for connection of this short circuit test, I have connected this S and M1. So this is red wire is connected to S and green wire is connected to M1. So between S and M1, our magnetic pickup coil is connected, and these two red and green wire are connected to the current source. Okay. And how much current we want to inject? We have to inject as per the instruction given by L&T in the manual. We have to pass 45 ampere of current if we are choosing the tap S and M1 as we have selected. If we select S and M2, then in that case we have to inject 57 ampere of current as per the instruction of L&T. So presently we have chosen S and M1, so we will inject 45 ampere of current, and for this 45 ampere of current we have to note down how much tripping time we are going to get. So the actual trip time we should get less than 25 milliseconds. See, less than 25 milliseconds. So we will get the tripping of the breaker less than a second. Less than a second. Okay, that we can put in the remark within a fraction of second ACB trips. That remark we have to write here in the remark column. And the actual time, let us see whether we are going to catch up in the timer, which will be less than 25 milliseconds actually. So let us see whether we are catching it or not. Otherwise we can write down here the remark, the ACB trips instantly within a fraction of second. Okay, so now we have kept the breaker in a closed position. See, breaker is in a closed position, and now I have to pass 45 ampere of current. Okay, so here approximately I have put this current source already here above 40. You can see here I have set it above 40 ampere approximately, and now I have to switch on this timer as well as the current source. So you will find that as soon as I switch on the current source and timer, at the same time you will see the braking, you can see the breaker is going to trip instantly. Okay, so let us see whether we can catch this or not. Okay, see, the breaker is instantly, you might have heard that. See, the breaker is in a open position now. Instantly, as soon as I start this current to inject, at the same time I got the tripping of the breaker. So in this way we can say that breaker trips instantly within fraction of the second. Okay.